Hi friends, in this video we are going to discuss about the concept of current division rule. So without current division rule, it is not possible to find the value of currents which are divided from the total currents in the different branches. Okay, so here the topic is, our topic is, so current division current division rule. So in electrical networks or circuits, the concept of current division rule is very important, because without knowing this current division rule, it is not possible to calculate the value of current which are flowing in the individual branches. Okay, for example, the question is find the value of current flowing in particular resistance. Then with the help of current division rule only, it is possible to calculate. Okay, actually the meaning of current division rule is what? Current division rule means when the current is dividing, we need to find that particular divided current. Then for that we need to use this current division rule. Okay, so for example, I'm going to consider one network, and in that network, so how we are going to apply this current division rule in the electrical networks, so we will discuss. Now see, for example, this is one resistance, for example R1, and for example this one is resistance R2, and this is the another resistance, for example R3, and for example we are applying some voltage here, and for that we are using one voltage, DC voltage source here. Clear? So this is a network. Okay, now for example here the applied voltage is equal to, for example, 50 volts, and for example see here R1, R2, R3 are the three individual resistances are connected in the network, and we know that this point is what? Node. Okay, I'm highlighting this point, just see here. So this point is the node. What is the meaning of node? Node means the meeting point or the connecting point of individual resistances. Just see here, R1 is connected here, R2 is connected here, R3 is also connected here. It means node or junction, both are same. Okay, junction or node means the meaning is same. Clear? Now see here, just observe this network here. We are applying some voltage, that is V is equal to 50 volts for this network, means definitely some amount of current is flowing through this particular R1 resistance, and this current is always starting from this terminal or this point, and it will again end at this point actually. But here what is happening, when current is supplied by this voltage source, V is equal to 50 voltage source, then this current is directly flowing like this, and it will reaches this junction point. After this junction point, what is happening, current will divides in this branch, and also some amount of current will divides in this branch, and the magnitude of this current flowing in this branch and the current flowing in this branch, it means the magnitude of current is always depending upon the value of resistances which are connected in this branch, because we know that the expression given by the Ohm's law is equal to what? I is equal to V divided by R, and from this expression we can say that current is directly proportional to voltage, but current is inversely proportional to the value of resistance. It means what? With the help of this expression, we can easily find the magnitude of current which is flowing in R2 branch and R3 branch. For example, see, for maximum value of current, the resistance always minimum. Okay, for minimum value of current, the resistance is always maximum. That is the reason why what I am telling you, when the magnitude of current is more, means the value of resistance is less. The value of current is less means the value of resistance is more. So that is the reason why after this current I1 is reaching to this point, after this point the current will divides in R2 branch as well as in R3 branch, and the current flowing in R2 and R3 always decided by the value of R2 which is connected in this branch and in this branch. For example, what I am doing, the value of R1 is, for example, I am taking 1 ohm, and the value of R2 is, for example, I am taking 10 ohms, and the value of R3 is, for example, I am taking 20 ohms. Okay, and for example, what I am telling you, the current supplied by this 50 voltage source is, for example, 10 ampere. For example, I am telling you the current supplied by this particular 50 voltage source is 10 amperes. It means this 10 ampere current is directly flowing through R1 and it will reach us here. It means at this point the value of total current available is 10 amperes. Clear? And from this total current 10 amperes, some amount of current will flows through this particular branch and some amount of current is flows through this particular branch. But we know that how much of amount of current is flowing through this particular path. So to find out that particular thing, so we are going for the concept of current division rule. Okay, now here we know that, for example, see here, the total amount of current which is available at this junction point is 10 ampere, but we can say that the value of R2 is 10 ohms, the value of R3 is 20 ohms. It means in R3 branch the value of resistance is more, but in case of R2 the value of resistance is less compared to R3. So that is the reason why definitely the current flowing in R2 is always more when compared to the current flowing in R3. But we know that 10 ampere of current is available at this point, means definitely the current flowing in R2 and the current flowing in R3, if you are going to calculate these two values and if you are adding these two, then you will get the value of what? 10 amperes. So that is the reason from this total current 10 amperes, some amount of current will dividing and it is flowing through R2 and some amount of current is dividing and flowing through this particular R3. So to find this divided current from the total current which is available at this junction point, so for that only we are going for the concept of current division rule. Okay, now see here, the formula given by the current division rule is, so current division rule formula, we can also call it as in shortcut CDR. So CDR means current division rule. Now current division rule is always given by the formula is, so here the total current into opposite resistance divided by total resistance. So this is the formula providing by what? Current division rule. Now see here, what is the meaning of here total current means, just observe this network. Total current means how much amount of current is available at this junction point. That current represents the total current. In this problem, I is equal to 10 ampere is the total current. Now coming to opposite resistance and total resistance means, for example, we are calculating the value of current which is flowing in R2 means the opposite resistance is R3. For example, we are calculating the value of current flowing in R3 means the opposite resistance is R2. Sir, why we are taking only R2 and R3? Why we are not considering this R1 while we are calculating this value means, just see here, after this junction point only current is dividing. But before this junction point, current is not dividing. It means current is flowing through this R1 is maximum. That is the reason why we are not considering this R1 here. But coming to R2 and R3, after this junction point, we have two branches, and in that two branches, we have R2 and R3. That is the reason why we are only considering R2 and R3. If we are calculating the value of current which is divided and which is flowing in R2, so while we are calculating that one, the opposite resistance is always R3. If we are calculating the value of current which is flowing in R3, always the opposite resistance is R2. Okay, so with the help of this only, we are going to substitute the value of opposite resistance. But what is the value of total resistance here? Total resistance means in how many branches the current is dividing from this junction point. So we need to consider all those resistances and we need to directly add. Okay, so in this problem, the total current is 10 ampere and opposite resistance. For example, the question is find the value of current flowing in R2 ohm. Okay, just see here, find the value of current flowing in R2 ohm. It means we need to find the value of current which is flowing in only this particular R2. So that is the reason why by using the definition, the total current is 10 and opposite resistance is always R3 divided by total resistance, means directly we can add R2 plus R3. Now we can say that 10 ampere and substitute the value of R2 20 divided by the value of R2 is 10 plus the value of R3 is 20. By simplifying this, you will get the value of what? 10 into 20 divided by 30. Here 0 gets cancelled, then 10 into 2 divided by 3, that is what? 20 divided by 3 is the current which is flowing in R2. Okay, for example, if you are going to find the value of current which is flowing in, for example, R3, then how to use this formula? So current flowing in R3 is equal to total current 10, opposite resistance is what? R2 divided by the addition of R2 and R3, because current is dividing in R2 and R3, that is equal to 10 into R2. R2 is how much? 10 divided by R2 is how much? 10 plus R3 is how much? 20. Now simplifying this one, you will get the value of current flowing in R3. Okay, so in this case, how we are following to apply this current division rule? So in every problem, we have to use this formula in the same manner to find the values of currents which are divided from the total value of current which is available at this junction point. Okay, so this is the concept of current division rule. Okay, so thank you so much for watching and please do subscribe my channel for more updates. Thank you.